Find an equation of the line tangent to the curve at the point corresponding to the given value of the parameter. Here, x equals cosine of theta plus sine of 2 theta, y equals sine of theta plus cosine of 2 theta, and the given value of the parameter is theta equals 0. If we're going to find an equation of the tangent line to the curve at this point, we should use the point slope form. And so we're going to need a point that's on the line. We find a point on the line by evaluating the x and y equations at theta equals 0. So if theta equals 0, then x is equal to the cosine of 0 plus the sine of 2 times 0. Cosine of 0 is equal to 1. 2 times 0 is 0. Sine of 0 is 0. So x here is equal to 1. Y is equal to the sine of 0 plus the cosine of 2 times 0. The sine of 0 is 0. Cosine of 2 times 0. 2 times 0 is 0. Cosine of 0 is 1. So y is also 1. So these points, these two coordinates come together and give us a point on the line 1, 1. The other thing that we need for an equation of the tangent line, we need a point, which we just found. The other thing is the slope of the line. Because this is a tangent line, we can find the slope using the derivative. So dy dx. And we're going to evaluate dy dx when theta, the parameter, is equal to 0, because this is the point corresponding to that value is where this line is tangent to the curve. Remember that dy dx is equal to dy d theta, the parameter is theta this time, divided by dx d theta. This is how we find the derivative if we're given a set of parametric equations, and then we're going to evaluate that when theta is 0. So dy d theta, y is equal to the sine of theta plus cosine of 2 theta. So dy d theta would be cosine of theta minus sine of 2 theta times 2. Chain rule. When we do the derivative of the cosine of 2 theta, we have to do the derivative of the outside function, which is the cosine of something, and we have to multiply by that by the derivative of the inside. The inside is 2 theta, its derivative is 2. Okay, we divide that by the derivative of x with respect to theta. X is equal to the cosine of theta plus sine of 2 theta, so its derivative is negative sine of theta plus cosine of 2 theta times 2. And we're going to evaluate this derivative when theta is equal to 0. We could do some simplification, or we could go ahead and put theta equals 0 in. Let's go ahead and do that. So here we would have the cosine of 0 minus the sine of 2 times 0 times 2 divided by negative sine of 0 plus the cosine of 2 times 0 times 2. One too many parentheses in there. Let's fix that. All right, simplifying. The cosine of 0 is 1 minus 2 times 0 is 0. Sine of 0 is 0. 0 times 2 is 0, so this is 0. Over negative sine of 0 is 0. Okay. 2 times 0 is 0. Cosine of 0 is 1. 1 times 2 is 2. So in the end, we have 1/2 for the slope of this tangent line. Remember, The point slope form of an equation of a line is y minus y1 equals m x minus x1. x1 and y1 are the coordinates of the point that are on the line, and m is the slope of the line. Above, we found out that the point 1, 1 is on the line. So we can say that our equation y minus 1 equals, and then x minus 1, but we have to multiply that by the slope. Well, we just found out the slope at this point is equal to 1/2. So an equation of the line tangent to the curve at the point corresponding to the value of the parameter theta equals 0 is y minus 1 equals 1/2 x minus 1.